Hello, so today we are going to do this problem, which is part of Leetcode daily challenge. So maximum points you can obtain from cards. So the problem says we have several cards that are arranged in a row, and each card is associated with a number. And we have the points that are given for each card in card points array. And you can take one card from the beginning or from the end of the row. And you can take up to k cards, exactly k cards actually. And the score is the sum of the points of the cards you have taken. And so given this card points array in the integer k, we want to return the maximum score. So we want to take k cards, but we are only allowed to take from the beginning or from the end. So if we take a look at this array here, k equal to 3, well, the best we can do is take 1, 6, 5, and that's it, 3, right? So that gives us 12. If you try to take like 1, 2, 3, that's smaller. If you try to take 1 from here, 1 from here, and then maybe 6, that's still smaller because that's 8. And so yeah, this is the max. For this one where k equals to 2, well, you can either take this, or you could take it like this, or you could do like this, right? All of them ends up being 4. For this one, k equal to 7, the length of the array is 7, so you take everything. And of course, the way you take it is either like this: you take this one first, take the second, you keep going from the end, or you could keep going from the beginning, or you can keep alternating. It doesn't matter really, because you take everything. Yeah, so this is the problem. Now let's see how we can solve it. Okay, so how can we solve this? So you can think of maybe doing brute force, but then that would be doing too many tries, right? Because you would have to try taking all of the end and all of them from the beginning, and then alternating. So it's a lot of work, so it probably will time out. So another way to think about it, actually, that would be that will get us somewhere is, if we have the array like this here, right? So what we want is we want the max score, right? So we want the max score after taking k cards. So what we can think of is what happens after taking those k cards. Well, we are left with a contiguous array, right? Because let's say we take maybe something from the beginning, like this black, and then we take from the end, and then maybe we take something, or we don't take anything, but this can be 0 elements here. So what we are left with is this subarray. But since we want to maximize this and this, well, what we want also is to be able to maximize that, we want to minimize this window. Now, what is the size of this window? We know that what we take here, these two, the green parts, are of size k, and the entire array is of size n. So what this would mean is that this here is of size n minus k, right? And so instead of looking for maximizing the score, we can just look for what is the minimum window of size n minus k, right? And then the score would be just the total sum of the entire array minus let's call this min window. It will be just the total minus the minimum window sum, right? Okay. And so now the problem becomes, actually, instead of like maximizing that score, which is a simpler version, problem becomes minimum contiguous subarray of length n minus k, right? And this here we can find with sliding window technique pretty easily, right? And so yeah, this is a good technique to kind of inverse the problem so that you can arrive at a near zero solution. Okay. Now, how can we do this problem here? So it should be pretty straightforward. What we need to do is just use a sliding window technique. So we will start with so let's have our array here, right? And so we'll start the index here at 0, and then we'll keep moving the end. So the end starts at Yeah, let me put some values here. So I'll say 1, 2, 3, 4, 5, 6, 1. And k equal to 3, so and here 3, 6, 7, and equal to 7, so n minus k is 4. And so we'll start here and end both at the start. So we fix start at 0 first, and then we have end, the end pointer moving, right? So it starts out here, and so now we keep the value, the sum, the current sum in value, in let's say maybe current, right? This would be the current sum of the window, and so with this start and end at value 1, it's 1, right? And we keep moving until we have a window of size n minus k. So we move end here, right? And now our window size is actually 1 plus 2, so it's 3. So we move end again, and the size is n minus k. The size here is 2, so we are not at 4 yet. So here we move end here, okay? And now it's 5, right? And so we move end again. The size is 3 at this point, so we move end here. And now this becomes 9. And now the size here, this is 4, right? So we reach its size. So when we reach size, we want to check, we want to keep track of the minimum window. So this is maybe the minimum window. So we want to keep track of it in case it's the minimum window. And so what we do here is we say the minimum window now is going to be the minimum of what was previously here, and with current, because the current is the sum of the current window. But since minimum window we haven't set anything, so we maybe initialize it to float infinity, and that way we'll end up with the value 9. Okay, so it's the min of the previous value, whatever was in min window, and the current. Okay, so now we move. Now the size is n minus k. And then we move end again, right? But now, since end is bigger than n minus k, the size that we want, we need to shrink the window, right? Because otherwise, this is bigger than the size we want. So we shrink the window by advancing size. And so what we do here is we advance start. So we advance start here. And so what this would mean here is basically we'll do two things. If the size of the window, which is just end minus start, is equal to the size that we want, so let's call this size. If it's equal to size, then, so this is +1 to get the exact length of the interval. So if it is equal to size, then what we want is to compute the min window, right? Which is going to be min of min window and the size, right? Which, and the current sum of the window, which is current. If the length is bigger than size, we want to shrink the window, right? So if it's bigger than size, then we want to shrink the window, which is just advancing start pointer. So we advance start by saying +1. Okay, but if we do current start +1, before doing that, we need to remove the value at start from the current sum, right? Because otherwise we will keep it in the sum, and so we do current minus the array at start. Okay, so in this case, when we shrink the window here, we need to remove the 1 from here, so this becomes 8. And now the size is 4, so we check if the new current is the min. And so it is smaller, so we remove this and put 8. And now we advance end again, and end becomes here. So we add 6, and that would be 6 here, 8 plus 6, that's 40, right? And now the size is 1, 2, 3, 4, 5, so it's bigger. So we need to move start again, and you get the idea. I'll stop here. This is 14 minus 3, that becomes 11. Since the size is 4, we check if it's the min. No, the min is still 8. And we keep going like this until we reach the end of the array. And this is the main idea. So pretty much it's a sliding window, and then once we have the main window, we can just, at the end of the loop, we can just return the total sum minus the main window, and that will give us the max score that we want, right? So this is the idea. Now let's code it up and just make sure it passes test cases. Okay, so let's write this solution and make sure it passes. So what we want is to have a start index, right? And we want that to be equal to 0. We want current to be equal to 0, right? That's the current sum. And min window will start it at infinity because we want any sum, the first sum to be smaller. And so then we go through the array moving end. And so this is the value, right? And so we'll do this, we'll enumerate card points. Okay, and now what we want is first to add the new value to the current value, and then we check our size, the size of the current window. So end minus start plus 1. If it's bigger than size, then we want to shrink the window, right? If it's equal, then we want to consider that window, right? Okay, so so here we shrink the window, and here we consider the window, or we take it basically. And so to shrink the window, we need to advance start pointer, but before doing that, we need to remove the value at start. So from card points, we want to remove the value at start. And here to consider the window, we just check initialize if we set min window to that current window if it's the smaller value. So we take the min of these two. Okay. And now we have our window value here, and then we return. Once we are done, we just need to return the total, which is the sum of all the values minus the minimum window. Okay, and that should be it. Yeah, that should be it. And so now let's run this and see if it passes test cases. And so yeah, we need to initialize size. Size is just n minus k, and n is just the length of the array, so card points minus k. Look like it passes these test cases, so let's submit. Okay, so that passes, yeah. Okay, so this is using indices. Actually, we can do this in a little bit more a simpler solution. And so what we can do is start current with the first k elements of the cards, right? So that would be card points in Python. This would be size. So the first n minus k, that's what I meant. And so that would be this. So the first n minus k element, that would be current n min window, both would be equal to this. And now what we need is just to keep moving that window of size n minus k. Okay, and so to do that, let's just only keep this, but here what we want is to have, so I'll just make this be n so that this is a little bit more clear. So n is equal to this. And here we will move I in the range of n minus size, right? Because we want to keep moving by size. So we want to keep moving. So if we have like this, array like this, and then we'll keep moving, let's say n minus k equal to 3, we'll keep moving like this. Okay? And so here we'll stop when we are here, right? Because we just want that window. And so what we want is current. We want to update current each time we move I. So before we were here, right? If we are here, we want to remove this value and add this value. So what we want here is to take card points, and then what we want to add is size plus I, right? What we want to remove is I itself, so that would be minus at position I, right? So that would be, so here this would be I, right? And so we add this value, and then we remove this value, so that's minus here, and we want to add this value here, which is size plus I. So in this case, if size is 3, it's I plus 3. That's this window here of size 3, so it would be I plus 3. So that's what we are doing here. And then we just check if that's the minimum window. And then at the end, we do the same thing. We take the sum minus the minimum window. Okay? So yeah, that's pretty much it. Let's see. So one thing here is that we no longer need the start value. And that should be it. Let's run. Okay, current is the sum of the first window, the first block of size in minus k. Okay, so that looks good. Let's run this. Okay, so that passes test cases. In terms of time complexity here, we are doing one pass and then this sum, so it's O(n). In terms of space, we are only using these variables and no extra array, so it's of one space. Yeah, so that's, I think, pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.